All right, algebra 2, here's the last video for 4.4. We're going to go ahead and use this factoring knowledge that we've gained to do something that we've done in 4.3, which is finding the zeros, or again, x-intercepts, right? Remember that zeros are just another way to say x-intercepts. X-intercepts. And another word you're going to see for it is roots, right? Remember, those are all the same word, the same thing, okay? So let's go ahead and find it for part A. If you remember from 4.3, and hopefully forever from here on out, what we do to find the x-intercepts is we take our equation, 3x squared plus 10x minus 8, and set it equal to 0. But then again, the first thing we're going to have to do is factor this bad boy. Do we have a GCF here? Looks like no. So now let's do 8 times c, so 3 times negative 8 is negative 24. I need the factor pairs of negative 24 that are going to add up to 10. So we have 1 and 24, 2 and 12, 3 and 8, 4 and 6. There, it's negative, so one of these has to be negative in the pair. Since the middle term is positive, our bigger number is positive. So these smaller numbers, these baby numbers, are all negative. Which one of these is going to give us a positive 10? That would be negative 2 plus 12. 3x squared minus 2x plus 12x minus 8 equals 0. Let's go ahead and factor by grouping. From my first group, I can factor out just an x. I'm left with 3x minus 2. From my second group, first I stick down the plus, right? And I don't have a negative here in the first part of this group, so I don't need to factor out a negative. But I can factor out a 4. 3, x minus 2, not just x. Okay, we still have the equals 0. And now notice we have one term. They both have 3x minus 2 in common. We factor out the 3x minus 2, and we're left with x plus 4 equals 0. Now you know how to do it from here because this is what we did in 4.3. We set each of these equal to 0. So you want to be careful because maybe some of you have gotten in the habit of just looking at the last number and changing the sign and making that your x-intercept. But you want to make sure you go with this step as well because, for the second one, it's easy. We're just subtracting our 4 to each side. So you get negative 4. But here there's an extra step, right? Let's add over our 2. 3x equals 2. We have to now divide by 3. So then our answer is x is equal to 2/3. So those are our x-intercepts, 2/3 and negative 4 as ordered pairs. 2/3 comma 0, negative 4 comma 0 are our x-intercepts for this quadratic function. Let's see one more. Okay. Step number 1 is going to help us here, as you might already see. Remember, the first thing we do before that, though, is 5x squared minus 20x plus 20 is equal to 0. We do have a GCF here. 5. I can factor out a 5, x squared minus 4x plus 4. And now what I can do here is if I hate this 5 and I think it's ugly, I now have another side of the equation. And that helps me because when I do have that, when I have two sides of an equation, I can just divide, since this is 5 times this quantity, divide 5 on both sides. And now this 5 is non-existent. Equals 0 divided by 5 is 0. Cool. And now if you recognize this one, or if you don't, you can use the special patterns here. If you recognize it, you can go straight away. But notice that, factor pairs of 4 that add up to negative 4, that's going to be only negative 2 and negative 2 equals 0. Now, because I have the same, I just have to pick one. X minus 2 equals 0. X is 2. So our x-intercept is 2, 0. Beautiful, 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 beautiful. Let's do a word problem, you guys, to finish off this section. You have a rectangular quilt that is 5 feet by 4 feet. You want to use 10 square feet of fabric to add a border to the quilt. And it's going to be of uniform width. When we say uniform, that just means same. So all around the quilt, it's the same width. What should the width of the border be? Let's draw a picture first. Here's my beautiful quilt. I'm gonna, oh, well now it's not drawn to scale, but it's okay. Just don't worry about it. It's definitely not drawn to scale. And it's also very pretty. Okay, there's my quilt. And what I want to do is I'm going to first turn this little setting off, wrong setting. Sorry, there we go. I'm turning that setting off so it doesn't autocorrect my shapes. I'm gonna go ahead and add a border that all around, at least it should be, all around, is the same width. Okay, so I know the inside is 5 by 4 feet. It's a square, just ignore it. This is 5 and this is 4, not drawn to scale. And then we're solving for the width of the border. So we'll just call all of these widths x. So that is x long, this is x long, right here is x long, right here is x long, everywhere along the width is x, I guess wide, not long, right? So how are we gonna go about this? How are we gonna find this? Well, we know a few things. We know the area of the inside is 20 because 5 times 4. And we know the area of the border, so the area of the blue shaded piece, we know that too. We know that's going to be 10 square feet, right? 20 square feet. So we can kind of use that to our advantage a little bit. We know that if we go ahead and if we take this outer rectangle and subtract out the inner rectangle, so if I take the whole quilt and subtract out the non-border piece, I'm left with the border. Okay, and we know how long the border is. We know the border, or sorry, we know how much area the border is. We know the border is 10. So that's gonna be on the right side of my equation. And what I'm doing is and I'm gonna write it out in words maybe first. Outer area minus inner area. Okay, that way we know what we're doing here. Our outer area, we don't know that yet, so we're gonna hold off for a second on that. But we know the inner area is 20. So this is gonna be minus 20. Okay, so for our outer area, we need to know the length and the width. Because then when we find those two, I can multiply them to give me the area. Well, I know this is 5. And I know these two pieces are x. And if I connect all of that, I get that side. So 5 plus x is that length. 5 plus x is 2x plus 5. So this is 2x plus 5. Can you guess what this one is? 4 plus x plus x. So 2x plus 4 minus 20 equals 10. Okay, let's go ahead. Let's make our life easy for now. Let's add the 20 over to this side. So I get 2x plus 5, 2x plus 4 is equal to 30. Let's multiply this out. Go ahead and do that for yourself, but for the sake of time, this is going to multiply out to 4x squared plus 18x plus 20 equals 30. Now, if we're going to solve a quadratic equation, because notice how this is a quadratic, we got to subtract everything over to the left. We got to make sure everything's on the left. We want a 0 on the right. So let's subtract 30 over 4x squared plus 18x minus 10 is equal to 0. Now this is problems that we've done before, right? First step, is there a GCF? Yes, it's 2. 2, I'm left with 2x squared plus 9x minus 5 is equal to 0. I can divide that 2 over to make my life easy, and I'm left with just the inside of that. So 2x squared plus 9x minus 5 equals 0. Let's factor this. A times c, that's going to be negative 10. I want the factor pairs, so 1 and 10. Sorry, 1 and 10 and 2 and 5. One of them has to be negative. The bigger one is positive. So negative 1, negative 2. Negative 1 plus 10, is that our positive 9? Yes. So let's separate that. 2x squared minus x plus 10x minus 5 is equal to 0. Factor by grouping. I can factor out a x. I'm left with 2x minus 1. Slap down the positive. I can factor out a 5. I have 2x minus 1, all still equal to 0. My GCF for each of these two terms is 2x minus 1. 2x minus 1 times x plus 5 is equal to 0. Home stretch, solve. 2x minus 1 equals 0. X plus 5 equals 0. If I solve this one, I get 2x equals 1. X equals negative 5 over here. Over here, divide the 2 over. X is 1/2. Oop, I drew too many lines. Sorry about that. X is equal to 1/2, or negative 5. Let's think about what x is. It's the width in feet of the border. We cannot have negative, so that rules out the negative answer. We can just kill it. X is equal to 1/2 a foot, or if you want to be technical, 6 inches. Yay, okay. Hopefully that sounds okay. If you were looking at that problem and you were wondering, oh, what if I set it up this way? There's actually a few different ways to set this one up, and it all depends on how you kind of configure everything. Instead of doing outer area minus inner area, I could have done the inner area plus the strip is equal to the total area. There are lots of different ways to set that one up, okay? Hopefully that sounds good, and I will see you in the next lesson, 4.5.